Hello students, I'm back again. This time we will talk about another searching technique, which is binary search. Binary search. So before we head to the actual working of the binary search, let us first classify, uh, differentiate between the linear search and binary search. As I have always mentioned, that make two columns in order to differentiate linear search and binary search. So I'm drawing a line to divide the board into two areas. Linear search, the first point of difference is um, search is search is sequential. Search is sequential. The search element the search element is compared with every element of the array in a sequence. I hope you understand. In a sequence means that if you have an array and your array index starts from 0, 1, 2, 3, 4 like this, then whatever you are searching for, x or s, okay, then it will be searched first over here, then here, then here, then here, and so on. So in a sequence, it will go always in a sequence. So if we write a point about binary search, then we'll say search begins with the middle element. Middle. So so from here you pay attention that what I am mentioning, because I have not yet explained what is binary search. I am just differentiating. So binary search begins with the middle element. So unlike linear search where we started with the first element, binary search begins with the middle element. So mark my words, middle. The search continues on either half till it is found. So this is one point of difference. So whether you find, not find, you will, if you have an array, so you are going to search for S in the middle element. Please pay attention, if the element that you are searching for, S, is not found in the middle, then you will decide to continue your search in either this part of the array or this part of the array. That means either the left or the right. You can't search for the entire array. Your search will be limited to any one of the halves. So that is why I have written here either halves. Next point is array need not be arranged in any order. Array need not be arranged in any order. So you can perform the linear search even if the array is not in a particular order. Binary search, point number 2, is array must be arranged. In an order. So you have to sort it. In my previous videos, you will find that there is sequential sort and binary sort, bubble sort, sorry. So those will help you to arrange your elements in a particular order. So once they are in an order, only then you can perform the binary search. Okay. So let's quickly now start with the binary search. So let us try to understand the technique first. We will take a horizontal layout again, divide it into 10 elements. So here you have 10 elements, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 elements. In these 10 elements, let us store values. So they may be in any random order. So it can be 6, 15, 2, then 9, 21, 14. This is 21, 14, 33, 48, 25, and say 10. So they are not in any order. So your first job in binary search is to get an array, input an array, store the values, declare an array, store the values, then perform sort. Perform a sort. Apply any sorting algorithm and rearrange it in a particular order. So I am arranging this in ascending order. So if I arrange this descending order, who will come first? 2 here, then 6, then 9, then 10, then 14, then 15, after 15, 21, then 25, then 33 and 48. So they are already in. Now we have arranged them. So the sorting algorithm that you can apply is any one of these, either the selection or the bubble. So you can apply any sorting algorithm and sort it. Understand that if you are already been given an array which is, there are many questions in the ICSE previous year's question paper where they have already given the array in a particular order and they are asking you to then perform the binary search. In that case, you don't have to sort. You can assign the elements in a particular order to the array and then immediately start your search. But if you are asked to define an array, declare an array and then store random values, then in that case the first thing that you need to do is sort. The second step is ask for the number. So input search element, input search value. So input the search value. So once you get the search value, let's say the search value is 25. Let's say this is what you're searching for. S is equal to 25. So what we do first is we divide the array in such a way that we have to reach the middle element. So we know that if we go according to the subscript, these are what? There are 10 elements. So what we will do, we'll take two variables, one to point to the beginning and one to point at the end. So one variable to point to the beginning and one variable to point to the end. I don't mean the values. I don't mean the values. What I mean is the subscript. The subscript. So here the beginning and end will point to 0 and 9 so that you can calculate the midpoint. So mid will be beginning plus end whole thing divided by 2. So the integer value that will come out is 4. 0 plus 9 is 9. 9 divided by 2 is 4 in integer. So there is no decimal point. So now we search whether 25 is there in the fourth subscript, whether it is here. So clearly it's evident that 25 is not here. 25 is not here. So immediately, so that means the first thing that we do is we check. First is sort, second is we input, third is we calculate the midpoint, Then fourth point is we check if the search value matches the mid value, which is name of the array followed by what? The subscript will be the mid value. So they are not matching. 25 is not equal to 14. So what we do? We use an else if. We use an else if to check whether s is smaller. That means the value that you're searching for, 25, is smaller than this value, 14. So is it smaller than the value at mid position? No. 25 is not smaller than 14. So what we'll do is we'll go to the else part then. So in the else part, what we do is we narrow down our search. That means we are sure now, we are sure as programmers, we are sure that whatever we are searching for, that is in S, which is 25, is not possible that it will exist on the left side of 14. So we are eradicating this part. So we will concentrate now only on the right side of the array. So what we do is we change the position of beginning to mid plus 1. Mid plus 1. So this fellow now no longer points there. It points to whom? 5. So you recalculate, again go back to third step. You calculate how much is the mid position. Mid position is beginning is 5 plus end is 9. So 5 plus 9 whole thing divided by 2. So 5 plus 9 is 14, divided by 2 is how much? 7. So since the midpoint is now 7, so midpoint will no longer point to 14 or 4. It will point to 7. That means it's pointing to whom? 25. So we check if the search element, which is 25, is matching with array of 7, which is also 25. So they match. So you say the search is successful. So in case you are searching for a value, for example, say 9. You're searching for 9 or you're searching for 6. Then you'll realize that first time it doesn't match with the mid element. So you check whether it is smaller than the mid element. So in case it is smaller than the mid element, what we do is we shift the end position to mid position minus 1. So that is how we narrow down our search on either half of the array. So you can pause and watch it again repeatedly to understand how we perform the binary search. Now let us look at the code. So the code is also pretty simple. What you need to do is take two variables, beginning, which will point to the first subscript, and end, which will point to the subscript number 9. You need a search variable. You need a mid value, mid. Okay. Then you need to declare the array arr equal to new int 10. So this will help you to declare the array. I'm just writing here perform input, take one I, which is the subscript variable. You will need this I to run the loop to perform the input. Then ask system.out.print enter number to search. Enter number to search. Remember, we did not take one variable, we need one more variable, which is whether our search was successful. So C equals to 0. So if our C remains 0, that means our search was not successful. And just like a counter variable. So we do now, we ask S is equal to sc dot next int. So in my previous video also I had mentioned that I will be using the scanner class to perform the input. There is an alternate way you can also perform the input. Now we start with a while loop mentioning that the value of beginning should always be less than or equal to the value of end. That is the condition to run the loop. So they should not exceed each other. as long as beginning is less than or equal to n, the loop will continue. So now inside what we do, we first of all we calculate the value of mid. So mid is what? Beginning plus n divided by 2. Then you check if the search element, this fellow, is equal to ARR of mid. So if it is matching, what do? As I told you, C plus plus means you count. That means your variable of C will increase by 1, which is an indication. So it's an indicator variable, which is an indication that your search was successful. And immediately what do? You break. So no need to continue anymore search. Otherwise you check, in case it doesn't match, then you check whether S is less than ARR of mid. If this is the case, then what do? I told you, when it is less, you bring down the value of end to mid minus 1. Otherwise, you say beginning is equal to mid plus 1. So this way you are dividing the array into 2 and then continuing your search on one of the halves. So after that you can say easily that if the value of C is equal to 0, means search was not successful. Search was not successful. Okay? Not successful. Otherwise what you can say, else search was successful. So you can try the code. Thank you.